Hello everyone. Today we'll solve some of gate questions in analog and digital communication. First, let's see in amplitude modulation. An amplitude modulator has output in volts. S of t amplitude modulated signal is given A cos 400 pi t plus B cos 360 pi t plus B cos 440 pi t. Carrier power is normalized to 1 ohm resistance is 50 watts. The ratio of total sideband power to the total power is 1 by 9. The value of B in volts is what? They have asked rounded to 2 decimal places. This is a gate question asked in 2024. Let's solve this. So first they have given S of t amplitude modulated signal as A cos 400, B cos 360 and B cos 440. So from this we can state that carrier frequency is 400 pi t and message frequency is 40. So FC plus FM is 440 and FC minus FM is 360 pi t. So carrier A cos carrier part வந்து A cos 400 pi t. So FC is 200 hertz. So sideband from this we can state that 2 FC plus FM pi. So divide by 2 if we substitute now 360 divided by 2 180 hertz. Second sideband 220 hertz we'll get. So then they have given that PC is equal to 50 watts. Carrier power 50 watts they give. So PC is equal to A squared by 2. Amplitude squared by 2 is a power as we know. From this PC is equal to 50. So we substitute A squared is equal to 100. So A is equal to 10 volts. So for carrier part we found that carrier amplitude is 10 volts. So same way if we find for sideband power per sideband is B squared by 2. Total sideband we have 2 sidebands no, so 2 into B squared by 2 will get sideband power as B square. So we don't know the direct power of sideband, but they gave us a ratio PSB by P total. So P sideband by P total is equal to B squared by total power. So A squared plus B squared. So from this 50 plus B squared if we substitute, which is equal to 1 by 9, they gave us the ratio. We cross multiply 9B squared is equal to 50 plus B squared. So 9 minus B squared, 8B squared is equal to 50. B squared is equal to 6.25. B is equal to 2.5 volt. So they asked us to find the value of B. We found that B is equal to 2.5 volt amplitude for the sideband. So next question we'll see in phase modulation. So in phase modulation they gave the question as SPM of t and SM of t are defined below, are phase modulated and frequency modulated waveforms respectively corresponding to the message signal M of t. So shown in the figure, they gave us a figure. SPM of t is equal to cos 1000 pi t plus KPM of t and SFM of t is equal to cos 1000 pi t KF into integral of minus infinity to t m of tau d tau. If the highest instantaneous frequencies of SPM of t and SM of t are same, then ratio of KP by KF is what they have asked. So they asked us to assume that SPM of t and FM of t have the maximum frequencies and that are equal. So from that we have to find the ratio KP by KF. Okay, wow. They have gave us the M of t signal as this. So 10 volt is the maximum. 1 to 7 it has the graph. Let's solve this sum. So first for phase modulation part, SPM of t they gave cos 1000 pi t plus KPM of t. So from this the part given inside the cos will be taken as theta. Theta of t is equal to 1000 pi t plus KPM of t. Omega is the differentiation of theta. So omega is equal to 1000 pi plus Kp dm of t by dt. So we have to find this part dm of t by dt. From the graph, what is the maximum value? we saw that the maximum value for the graph is 10 volts. So 10 volts, the differentiation, the 10 volts can be reached in 2 seconds. That is from 1 to 3 in the graph. 1 is the initial. From 1 to 3 it reaches the 10 volts. So slope, the dm of t by dt is the slope, by the way. So in 2 seconds it reaches. So 10 by 2, which is equal to 5. Similarly, for Fm, if we solve, yes, Fm of t is equal to cos 1000 pi t plus kf integral of minus t to t m of tau d tau. So from this we can state this is the theta I of t 1000 pi t plus kf integral m tau d tau. Omega is differentiation of theta. So 1000 pi plus, if we integrate, if we differentiate this part, integration gets cancelled. So kf into m of t. So from the graph directly we can say that the maximum value of m of t is 10. No slope or differentiation required here. So this is a major part. They gave us to equalize the maximum frequencies. So fpm of t maximum is equal to ffm of t. So kp into maximum of dm of t by dt, which value we found, which is equal to kf into maximum of m of t. So this one we found as value 5. Then maximum of m of t is found as value 10. If we substitute, kp by kf ratio is 10 by 5, which is equal to 2. Thank you.